So, I'm trying to make something and it isn't going as well as I'd like. And I finally conceded that I need some small metal parts that are heat resistant and abrasion resistant. But I can't 3D print metal. I also want them to be replicatable so that other people can copy my design easily. I'm going to try and form some metal parts using 3D printed tooling. Oh, and I don't have a press either, so I guess I'll just try 3D print my way out of all my problems and make a video out of this little side quest. I decided that I needed to form my part using multiple operations, starting with this curved feature. My thinking is that I could use this to locate the part for the remaining operations. My concept was really simple. Take a strip of steel viewed from the side, then print a part for it to rest on and hold one end, then another part that has a round cutout that will also cover the top, and then when the upper part is driven sideways, the strip of steel will ride around the cutout and form the round. I very quickly printed some parts, then installed a few threaded inserts with my half-completed threaded insert press. This first test was very easy to assemble. I used a long M5 bolt to pull the two parts of the tooling together. I added a pair of M5 nuts on the end of the bolt, locked together so that I could drive the tooling both ways. This is the material I will be using, some 10mm by 0.5mm steel that I bought on Amazon. Link in the description. If you're going to try this, I would recommend using some metal shears, unlike me using some old rusty garden shears. To mark the length I need, I'm going to colour in an area with black Sharpie, then mark the length with a vernier. After hacking the piece off, it's best to file away any burrs. Now I can secure the blank in position with this top piece and 4 M3 bolts. Do you think it will work? Well, the answer is no, it didn't work, and there is a very easy explanation. Metal is stronger than plastic, and it's easier for this thin edge of metal to just destroy this piece of plastic than it is for it to form around this tight radius. Which in retrospect seems kind of obvious. Undeterred, I decided to try something else, something more press-like. So I designed this block of plastic. At least by having interchangeable tooling, I should be able to reuse this press type item over and over again. I also decided that a 3/4 round might be asking too much, so I'll try for 180. And the tooling concept is very different. This time the blank sits loosely on top of the lower tooling. The upper tooling has a 3mm metal pin in it that will push the blank into a vertical form, generating the 180-degree bend. What are the odds this will work? I feel a lot more confident. and it's worked very nicely. If we view the footage again from above, we can see the blank bending here. Now, to form the rest of the features. The next step is to introduce this stepped feature. So another set of tooling inserts, and I was ready to try. This time, I made the tooling suitable so that it could make left hand or right hand parts, by simply mounting it in the opposite side. I used a 3mm metal pin to locate our previously formed piece via the 180° bend. And it doesn't look like anything has really happened, so I tried again. And you can see that it has changed shape. If I hold it up against an M5 insert, it does sort of match. The lesson here though is that computer-aided design has skewed my expectations. If we look at the concept again, it looks great, and it's easy to imagine that these parts would form around the insert well. But on the computer screen there is no concept of scale. Let's remember that this is 0.5mm thick, and this offset from here to here is a grand total of 0.4mm thick. So if we assume our part is springing back slightly, and when we mount it to something the position might not be very precise, suddenly that 0.4mm bend is nothing. With this in mind, I changed my concept once again. There are now 4 stages. The first one is the same, and now the second stage aims to fold that bend further, much like the original concept. The third stage has a much more pronounced bend, rather than several smaller step bends. The final stage, which we have yet to try, adds a small perpendicular bend to try to retain the insert. And of course, this required nearly all new tooling. So I printed another batch of tooling and tried them out. This is stage 1. Which, as we know, has good results. This is stage 2. Which more sort of folded the flat down rather than curving it. I think there is too much lateral movement of the tooling, but a semi-success. This is stage 3. I'm really happy with how this turned out. And this is the dreaded final stage. I'm a bit concerned this might just try to flatten the previous stage. And it came out okay. Certainly not a 10 out of 10 result, but I think this will be a usable part. I don't think this is the end of my metal forming side quest though. I think I need a better 3D printed press, and the ability to press with more force. I did end up stripping the print where the M5 nut sits and bending the bolt. So definitely room for improvement. If you want to see if I can make an auto reloading threaded insert press, consider subscribing. See you in the next one.